Hi, and welcome to this next video from the Year 2 differentiation content. Last video we had a look at product rule. Let's have a look at the division equivalent, which is quotient rule. So in the previous video we looked at how we're going to differentiate a product, something in the form f of x, g of x. This one's going to be what happens if we're dealing with f of x divided by g of x. Okay, off we go. Now in the previous video it turned into a bit of a behemoth, as I showed you where product rule came from. This one we're not going to do it in exactly the same way. There's basically a similar trick to the proof of product rule. Will work also on quotient rule, but what I'm going to do is just jump to the results, and there it is. It's not quite as nice and tidy as product rule, but there's a few things to note. Firstly, what we've got here is the same structure as product rule. Differentiate one, leave the other one alone, leave that one alone, differentiate that one. But in this particular case, because it's a subtraction rather than an addition, it does matter which way around you do it. So it's got to be differentiate the numerator, leave the denominator alone, minus, leave the numerator alone, differentiate the denominator. And you've also got this slightly bizarre kind of just division by the denominator squared on the bottom. And because of that, because it's not quite straightforward, you'll notice I've put in note number 3 down here. Quotient rule is one that is given on the formula sheet. Product rule is not. You have to know your product rule, but you can always refer back to your quotient rule. And I generally still refer back to quotient rule just to make sure I'm getting it the right way around, because the last thing I want to do is have it the wrong way around and end up with a sign error. So there you go, that's quotient rule. So let's have a look at how we'd go about using it. So here's our first one. We've got d dx of sine 3x over 4x cubed. So we've got a big division. What we've got to do is we've got to differentiate differentiate f of x, to differentiate the numerator. So that's going to become 3 cos 3x. And then multiply that by the denominator left alone, so that's the 4x cubed, there it is. And then I've got to subtract from that f of x, which is the sine 3 of x, times by the differential of 4x cubed, which is 12x squared. And there you go, there's your 4 bits on the top. And we've got to divide that by 4x cubed, all squared on the bottom. There you go. So there's the initial structure. So now let's just do a little bit of tidying up. So multiply out the brackets on the top, and we can see we've got some cancelling that can go on. So we can cancel out an x squared, and we can cancel the kind of the 12 over 16. So it all becomes 3 bracket x cos 3x minus sine 3x divided by 4x to the power 4, and there we go. And we go to part B. So we've got a log function over a quadratic. So off we go again. So differentiate the log function. So again by inspection, so we've got 2x over x squared plus 3, and we've got to times that by the numerator, so times that by x squared plus 3, and then subtract ln x squared plus 3 times by, and it's going to be 2x, all divided by x squared plus 3 all squared. And it looks like a bit of a mare, but you can see clearly we've got some cancelling going on in the numerator. So those x squared plus 3's will cancel, and I can take a factor of 2x out of that numerator, so there we go. 2x bracket 1 minus ln x squared plus 3 all over x squared plus 3 all squared. Right, so that one turned out to be possibly a little bit more simple than we might have anticipated, which is all good news. Let's now have a look at differentiating tan x, and tan x is a result that is given to you in the formula sheet, but what we're going to do is prove that result using quotient rule. So earlier on in the course we differentiated sine and cos and very deliberately left out tan, because it's a bit more of a trick and you need quotient rule to be able to do it. And there we go, we're going to do it by doing sine x over cos x. Let's go quotient rule, so differentiate sine x, which is cos x, times that by cos x, subtract, leave the sine x alone, differentiate the cos x, differentiate cos, remember, minus sine, divided by cos x all squared. And you'll notice on the top what we've got now is cos squared, and we've got a minus and a minus there, makes that one into a plus, cos squared plus sine squared on the top, and clearly we know that that's going to become 1 over cos squared, and 1 over cos squared is sec squared. So as it turns out, differentiate tan, you get sec squared. And then the final one we're going to do, we're going to differentiate sec x, which we saw in a previous video where I did it using chain rule by writing it as cos x to the minus 1. But this time what I'm going to do is write sec as 1 over cos x. So in this one we've got f of x is the 1, g of x is the cos x, so off we go. So differentiate 1, I get 0, so times by cos x, there it is, and then subtract 1 times by the differential of cos, which is minus sine, and then I've got the cos squared on the bottom. So we've got sine x over cos squared x, and again from here on in it's the same as we did previously, sine x over cos x times by 1 over cos x. So that gives me tan x times by sec x. So we get the same result doing it using quotient rule. And there we go.